as well as Oleg from Atomicjar, correct? Sorry.
Yes.
Okay.
Perfect.
So we're going to talk about test containers today, which I always, every time I run into Oleg, we always talk test containers. So this should be a really fun, exciting talking about application testing using ephemeral instances of Neo4j. So Michael and Oleg, take it away.
Perfect.
Yeah, hello everybody. We are completely clueless on what we are doing here to some extent, but we thought about having a nice conversation how about Neo4j and test containers actually met, and how we started this endeavor from the perspective of someone who writes code using the Neo4j Java driver, Java connectivity, and is one of the maintainers of Spring Data Neo4j. So this was basically about me. What about you, Oleg? What's the story here?
Well, I work for Atomicjar, which is the company made by the maintainers of the Testcontainers libraries. And we are on a mission to improve the developer experience and productivity via, well, different tools, right? And, well, the most popular are the open source Testcontainers libraries. They are available in different languages, which is good. My personal experience is in Java as well, which helps here. Maybe is a little bit detrimental in other contexts, but no, I love Java. Java is a great language, and the recent advancements are have been very fast paced. Right? So personally, I'm having a little bit of trouble keeping track of the versions and what came in which version, but I just know that it advances forward. So I love it. I love Java. My experience is mostly in Java, and well, of course, I've used test containers for a number of years before even joining Atomicjar, and I knew people at the company from very early days in my career. So it was a very exciting opportunity.
Yeah,
and
thanks.
test containers, if you don't know, well, then first of all, you are in the right place. But how this particular call happened is that test containers gives you the API to sort of do things with containers for the pre-production use cases, mostly targeting pre-production use cases. And then because it's a library in the language, it is a natural place to allow for abstractions, right? We can make use of abstractions there, which is how test containers came up with the ecosystem of modules, right? So we can run any technology that is runnable in a Docker container programmatically, but, well, not everyone needs to or wants to learn how to run particular things, right? So and test containers has the library that helps developers run particular technologies. One of them is, for example, Neo4j. There are many modules for other technologies like relational databases and NoSQL databases and message brokers, and I don't know, like a Selenium container, or I don't know, Elasticsearch container, anything, literally almost anything that is runnable in containers has a module, but also Neo4j. And that's how this call happened. Is there is a definite synergy between different technologies. So in preparation, Michael was very humble in saying that we don't know what's going to happen. We do know what's going to happen. In the preparation, we wanted to outline some particular message or what things that we would like to show, right? And Michael, you mentioned that very often people, at least in the past, maybe these days now as well, when we test, when we want to run integration tests specifically for applications, right? Sometimes people don't know how to recreate the production-like setups easily,
Yeah,
or at least run with reasonable things. And then very often developers reach for the embedded solutions, which are sort of like advanced mocks, if
exactly.
you will, a little bit advanced mocks. And the most commonly known is probably H2, which is a relational in-memory database for relational databases. But also you mentioned that there is an embedded version of Neo4j
Exactly.
that
Yeah.
sometimes people use.
So probably the Neo4j people listening to this or watching this stream are aware that Neo4j is written in Java and runs on a JVM, or I have to say Neo4j is written to most extents in Java. There's a lot of Scala involved as well. It runs on a JVM, and it's basically a great candidate for being embedded. This has some valid use cases in the past, and I think so today. And we have dedicated means of using Neo4j embedded for testing purposes, which is also great. Makes a lot of sense if you want to enhance Neo4j with custom stored procedures, which is quite possible as well, written in Java. So I would never object using Neo4j embedded for testing stored procedures in Neo4j or developing it. But from our perspective, doing client-side stuff, it's one way to integration test your application, but not a way that is sustainable. And I love it that Oleg mentioned the fast-paced development of Java the last years. It's great that Java is moving forward. And we do a lot of stuff to bend Java to our will in Neo4j to make Neo4j perform great. And we do a lot of things that might be considered unsafe, for example, with off-heap memory and what have you. And we need to fine-tune the Java runtime, which changes quite a lot from Java version to Java version. So there you will already have issues when you just use Neo4j embedded with your application and you don't. I was just reading the message that just popped up on my screen, sorry. And yeah, you need to fine-tune your JVM. And Oleg and I prepared a project to show you what this means, and I'm going to share my screen and try to talk while doing so. So I'm going to share the whole, just share my IDE. This window. I hope this is readable enough. Can anybody confirm this?
Big enough? We can see it. We can see it.
See and even read.
Well, it's a little bit blurry, but I don't know if this is my
blurry.
eyesight.
Just increase the size a bit.
Yeah,
so we did not try to go very much deep into Spring Data Neo4j or whatnot. I didn't even bring in Spring Data Neo4j here. We created a simple Java object named movie and a completely homegrown repository. That repository takes this thing, which is called driver, that's a database connection inside our system, and runs a query and just creates a node inside the graph. So it's not that important what it's doing here. We just needed to have some things we need to test with a database connection. In real life, it maybe would have been an interface, so we could mock it away. But at some point, you really want to test the thing you're creating. For example, here I have a custom Cypher query. Cypher is the Neo4j language. I want to make sure it runs against the real thing. And I also want to make sure that all the connectivity that is behind those method calls does the right thing. So this is why I want to have a real integration test. Going to the real integration test, what we see here, Neo4j builders, this is using the Neo4j test harness. This is a specialized embedded Neo4j version that also has a way of opening a network connection. So it's kind of embedded into this application test, but also uses a proper network connection into it. So it's not like it's completely embedded, it's half-assed embedded, I'd say. This is a Spring Boot test. I'm using a feature called dynamic property sources. Forgot when that was introduced in Spring Boot, somewhere in the 2x series. It allows developers to modify Spring Boot values doing tests on the fly without messing with additional configuration classes. What I get here from this embedded instance is a connection URL, and I specify a username and password to be used. This will automatically feed into the Spring Boot auto configuration that configures that driver, that connection for me. I can happily run this thing here. And you see a lot of output. This is what Neo4j does internally to bring up this whole system. I'm quite happy. That test runs, it's green. I don't have any output here. So summing this up, embedding Neo4j is easy in a Java application if everything matches up, meaning JVM version and dependencies. When I go to my external libraries here, you see like, it doesn't matter what these are, but it's a ton of dependencies that gets added by a big database management system like Neo4j. Chances are high that some of those dependencies will mess up with your application dependencies. So in the repository we've set up, we already prepared a couple of steps. It's a Git repository. We can share this after during the session. I'm going to check out a second commit here. I think I need to double click this. How do I do this? Check out. And in that commit, I upgraded. The original project was using, damn it, was using a Spring Boot version 2.7, and I was using Neo4j version 4.4. That's an older version of Neo4j. I did this on purpose. Latest version is 5.13. So in the first attempt of upgrading this to Spring Boot 3.1 and Java 17, which is just by bumping the according versions 3.1.2 here and Java 17, I need, of course, upgrade my module settings here if I haven't done this in IntelliJ. Probably you're not able to see the dialog in the screen share.
We don't.
I
But
just
you adjust that. Just a bit of context. Spring Boot 3.1 baselines on 17. I think maybe
Yes.
even 3.0 baselines on Java 17.
Yes,
so
they do.
Upgrading Spring Boot requires us to bump the Java version as well. And then
Exactly.
from 11 to 17, that's actually quite some changes there.
It's quite some changes, especially on the module systems. Again, some things are more restricted than before. And yeah, let's see what happens if I run the test again. The code didn't change so far. It stays the same. Spring Boot is actually usually quite easy to upgrade, so it's not a Spring issue here at all. But what do I get when I try to run this? Java yells at me with a linkage error. I honestly haven't seen this for quite some time in anything I've done. What we see here, stuff in our unsafe utils just go upside down. They just don't work. Don't ask me what we do inside unsafe utils. Neo4j 4x is written for Java 11, and it's just not compatible with Java 17. So this is one of the first things that happen to you if you just let us embed something that big for testing. Right? You not only get the real thing in terms of behavior on the network, you also get a lot of other issues. Right?
Yeah.
So
just to be clear, this is not a Neo4j issue, and this is not a Java 17 issue, and this is not even the memory heap estimator code issue. This is just like a happy little accident that teaches us better ways.
A happy little accident that usually leads people into rabbit holes they don't want to go. Right? You could try to fumble around with Java runtime options. You could try to swap out individual dependencies. You can try a lot of things, but they usually end up in pain if you try to bend these systems over to your will in a ways that they're not meant to work with each other.
Yeah.
So
the immediate feedback, not feedback, the piece of advice for people watching. If you want to upgrade things like this, take a look at Open Rewrite and Modern.
Yep,
They provide
that's
the
a great
recipes
point.
for automatic migration, and chances that after applying those automatic like remediation changes to, well, hopefully you're not the first person to migrate Spring to 2.7 to Spring Boot 3.1, right? And there could be a recipe already that knows which parts needs to be changed and how much, and then your upgrade might be a little bit smoother. But this was
Exactly.
done for educational purposes. So
This is on purpose in that repository.
yes.
And we're going to show the other thing as well. You could say, okay, let's postpone the upgrade of Spring in the Java version, or at least the Spring version, and let's try to upgrade first Neo4j embedded to something that works with our system. And I've set this up as well. So in that commit here in step 2b, I kept the Spring Boot version, bumped to Java 17 because Neo4j 5 is Java 17 based. And you might think, no, the test is still the same. And you think this thing should probably now work and test again.
Well, while I don't fully know the outcome of this, I can with certainty say that this is not ideal, because I would like to
Exactly.
test against the version of Neo4j I'm going to use in production.
That's true.
And then I don't really want to test against the version of Neo4j that my sort of environment,
You
development
don't
environment.
want to tie the build system that closely to the one that you're
Yeah.
using in production. That's
Yeah.
exactly right. And what we have now, Neo4j does start, but then you have something that just clashes because now we are in dependency hell, that thing I mentioned earlier. You have a lot of dependencies from Spring, which is fair, and you also have a lot of dependencies from Neo4j. It's both, none of those are wrong. But if you try to force feed those things together, you end up in situations like that. This is not something you want to debug. And what Oleg just said, you just can't move easily around your testing environment. I mean, with a patch version, it's probably easy enough, but you're not able that easily point from database version n to database version n+1. And that's true not only for Neo4j, of course, it's true for other message brokers, for other databases as well. You want to have something that is configurable via just actually that parameter here. You want to just point it to something else.
Yeah. All right. So how do we make it right?
Yeah, we're gonna make it right in step 3. Let's jump back to the POM file. What did I do? We're gonna postpone both the Java and Spring upgrade. You should do these things usually in isolation. It's much easier. Gonna check out why it doesn't let me check it out. So no, everything is red. That's excellent. What did I do now? Back to Spring Boot 2.7, JDK 11, both is fine. But now I have included in my dependency management the test containers BOM, the bill of materials. I usually check if I include another dependency, whether those guys have a BOM file, so that I can rely on the dependencies they manage. This is quite nice for things like test containers. For JUnit, it's nice. They provide a consistent set of dependencies, and you can use anything that is managed in their BOM without always repeating the version number. So importing that the BOM file doesn't give you the dependencies, you need to ask for them first, which I do here for the Neo4j container. The test harness, the Neo4j embedded version, is now gone from the POM file, and the repository tests does look a bit different.
Okay.
Not that much, actually.
Do you want me to take over and like talk a little bit about the setup here?
Sure, if you want.
Okay, perfect.
Do you want to share your screen then?
Yes. Entire screen, boom, screen 2, run, share. All right.
Excellent.
Right. So this is our project, and if we look at the commits, we are on the step 3, right? So
Yes.
exactly where we were there. If we look at our test, it's the same test, but there are a number of changes. We can notice here we have instead of the Neo4j harness, we now have the Neo4j container abstraction, which comes from the Testcontainers library.
Exactly.
Right, from that jar file that we pulled as a dependency. And this is the abstraction that represents the Neo4j container that we're going to run through our tests or through our local setup programmatically. You can see it extends generic container. So in general, I can do, say, generic container, whatever container equals new generic container, and provide it with the Docker image name. It could be anything. Could be Redis, as my Copilot suggests, right? But it's an abstraction, and it gives me the ability to configure anything that I would like to configure on the container level. I can expose ports. I can override environment variables. I can specify the command if I want to run like a custom command for the particular Docker image. I can, of course, specify the company internal repositories, registries, Docker registry from which I will pull the thing. But I can specify all the things that I can do on the container level via the API. And then I can, of course, have the container lifecycle methods. For example, I can start it or I can stop it, and so forth, right? So I can configure this thing manually to run anything, but I don't know how to configure Neo4j, and luckily I have the module for this. This is what I meant by the ecosystem of modules. There are actually, I think, more than 50. So I don't need to know myself how to run Neo4j. I can just rely on the library, and the library will tell me which ports do I need to expose. It will tell what are the configuration for the credentials that are being used, right, and the authentication formats, and also the same set, like it will provide the wait strategy, which is how the Testcontainers library will know that the container, not just container started, but also the software in it, like Neo4j is actually ready for receiving
opening
queries.
connection.
Yeah, and receiving connections, opening connections, and open for business, so to speak. So it's all in the library. It's
And
also
you can see it in the Neo4j properties. So there's dedicated methods to get special information that is not in the generic container, like the bolt URL or the administrative password and stuff like that.
Exactly. So with the same argument, which with the same dynamic property source functionality from Spring Boot, which allows us to override the config by dynamically providing values, we now can do the following thing. We can define the container, and we're defining it as a static field here. In the before all, we actually instantiate the container to be of a particular Neo4j version. We override the waiting strategy for some reason, and we also start it. So before all the tests in this class start, we will start our Neo4j, and it will block until that instance is started. And then we configure our Spring application to use that Neo4j using the bolt URL and the credentials. So this should
Oleg,
work, right?
Yes, that should hopefully work. And while it starts, a colleague of mine asked me, why do I use neo4j.start or container.start method in contrast to the add container annotation, which is there in the JUnit Jupyter extension. The answer for that is quite simple. While I do use some annotations here from JUnit for test containers, namely the annotation in line 17, visible at the top at test containers, so that the test is disabled when there's no Docker available. I find this quite useful for people who just want to check out the project and build it. I don't use the add container annotation because that one messes with the flag I'm setting in line 26 with reuse. So there's one method that is available to the generic container as well with reuse. This allows the test containers to, or it tells test containers not to clean up the container after a test run. So what test containers usually would do is bring up a Reaper image called Ryuk that takes care of any container that is started doing a test and moves it away. If you do a lot of integration tests and you are sure that your integration tests are not dependent on each other and don't mess with the same data, it's quite safe and much faster to make use of reusable containers. They're not clean up after a test run, and if they are the same based on the image name and other configurations, they will be reused. And the add container annotation would just close them manually after the test run, which is definitely not what I want here. I want to reuse them.
Yeah. So thank you. This is a good question. This is actually a very, very good answer. And just to provide the little bit more context, we could have used the annotations from the JUnit integration provided by test containers. So in classes annotated with test containers and fields annotated with @container, the life cycle of those containers could be managed and tied to the life cycle of the tests, right? So a static field would become sort of a one instance per class, similar to before all, but like in the before all, it will be started, and in the after all, it will be stopped. So Neo4j stop would be called for that. Sometimes this is what you want. Sometimes this is not what you want, and you want to manage the life cycle of your instances manually, like we are doing here. But in general, this is a very common idiom. So if I put container and sort of if I would do this here, right, it's a little bit like this, right? So this would be even that if this is what we want, right? If we want the life cycle of Neo4j be tied to the life cycle of the tests in the class, right? This would be the idiom how I would configure my Neo4j instance without any additional boilerplate. So it's going to be just a few lines of code, right? So
and
let me
just
undo
for the
this.
record, there is not this is a wrong or right answer here. It's just really depending on your use case, as so many things. And a lot of the things I write or use test containers for are actually tons of integration tests for Spring Data Neo4j. And if I would tie the container to each integration test, it would just slow me down. It's quite fast these days, but if you have like hundreds of integration tests, it's not that fast anymore. So for us, it's usually small interactions, isolated data sets. This is the way to go to keep them alive. If those data sets are more complicated, we're probably better off using dedicated instances tied to your test lifecycle.
Yeah. So it's the trade-off between isolation of tests and isolation of test environments that we create, and sort of performance, right? Not in a sense how fast individual containers will run, but in a sense how maybe fast your whole CI pipeline will run. Right? Because
exactly.
locally or individual tests, right? So locally, I don't think you very often run the whole pipeline, maybe once before the commit. But if you have like hundreds and hundreds of integration tests, maybe not even then, but you just run like a subset.
Exactly.
Or run all of them, but parallelized. So it's a trade-off. Luckily, it's all in the code, so it's very, very easy to control as a developer. You just, easy. You need to understand what you want to do, and you need to write it in the code. Sort of very easy.
The beauty here is it's not rocket science to abstract the line number 35 away. If you have some code that gives you a bold URL, you can also go for some tests giving you local connections, right? It's way easier in that shape or form to decouple your build system from the thing under test.
So I can also do this if I want to and manually recreate that. So just want to show the complete flexibility. Right. This test run. Let me actually do the thing that I didn't do before. So there is a like a page in the documentation. Okay, here, come on. Screen, come again. Right, a page in the documentation called recommended logback configuration. Let me just very, very quickly
great point.
Put that file into well, here, I don't know. File.
I think it doesn't matter. It's going to be picked up from logback_test.xml if you put it in the,
we'll
test resources.
And then it's just, I think the output would be, what happened? Why are we not compiling? Right, so we could work, and then the output is a little bit nicer. What happens there is that my Testcontainers library defines my Docker environment, which is configured. I'm using Testcontainers Cloud via the Testcontainers desktop application, free application. You can check it out if you want to look at it. And then it starts Spring. It starts our Neo4j instance, and it runs.
So what Oleg just did was grabbing a logback XML configuration file from the docs and tuned down the logging a bit.
Yes, because by default,
even with an abstraction like Testcontainers, you will end up with dependencies having fun together. In this case, their Testcontainers picks up the Spring logging configuration by default and just dumps like everything it has, and it's kind of noisy. And yeah.
Yes, the reason for that is actually this Docker Java library. Testcontainers uses the Docker API. It doesn't use the command like you do on the command line where you do like Docker run container or something, right? It sends the API calls directly to the Docker daemon, which gives us way more flexibility in what we want to and what we can achieve. But yeah, you might want to configure logging a little bit, because by default that is a little bit verbose for my liking, at least. Okay, but this is how the test looks like, right? This is very easy. We say Neo4j, we wait, we configure Spring, right? 3 things. We need to configure our containers, we need to manage the lifecycle of our containers, and we need to tell our application where our technologies and containers are running. And after that, tests run in an environment which is ephemeral, but also very much production-like. How do we upgrade this now?
I just wanted to ask, Oleg, as a non-Neo4j person, would you be able to upgrade this to Neo4j 5?
Yes, I can do. Look, check this out. So we do Neo4j and we do 5, and then we wait for content assist to kick in. What's the version?
5.13, but I think 5 gives you just latest.
Okay, 5.13, maybe 0?
No, yeah, I think so.
Let's run it. This is, we changed the Docker image name, right? And then we are now maybe pulling it from the Docker
starting.
And it's starting, and then it runs.
And this is exactly how we want to decouple the thing we are testing from the database or service we're testing against it. So imagine not hard coding the image name here, just doing a system property, for example, and there's a couple of other ways to dynamically introduce that image name. And this is how we think integration testing should look like, and not hard tying 2 big things, an application framework and the database together, right?
Well, absolutely. If I want to upgrade, if I'm like upgrading my Neo4j like cluster or something, and I want to upgrade my versions, I can parameterize my tests with the different versions, run the test suits against the next version, and be confident that my application works with the next version, and then safely proceed with the upgrade. In general, why do we write tests, right? Tests are, well, some people write tests to pass the code review, which is a noble goal. But that also, you can get so much more out of the tests, right? Like you can actually write test suits that give you confidence and give you some signal about the quality of your software, right? This application is, of course, a little bit simplistic. So there is no, like from the tests, we don't get a lot of signal like, oh, does it actually work? Well, we do get a signal whether it works or not, but we don't need to deploy it in production. So we can maybe look at the code and then be confident. But what the good test suite will give you, it gives you the confidence to know that you didn't break anything. The stuff that needs to be working is working, and it also will give you the signal automatically, right? For that, you need to do sort of two global things. You want the tests to be repeatable, right? Which is what you get with test containers, because we clean up the environment, and sort of self-contained, so it runs everywhere the same way.
Some signal you want, or our customers are interested in. They ask us, hey, I want to upgrade from Neo4j 4.4 to 5. Do my queries still run in a good way? They want comparison between the old and new one without touching every aspect of their application. They already have custom queries, and they want to make sure that these queries still run in an optimized way. This is one way to do it. And yes, of course, what's missing in this simplistic application is, for example, a data fixture. There are a couple of ways to do this. You can mount file systems into the container. You can execute scripts inside the container during startup, or you could use a database migration tooling. We have a plugin for Liquibase that can do this. We have a custom tool of our own, which all hook into that system quite neatly, actually. So this is also an aspect of testing, I think, that is quite important for a lot of customers.
Yeah, right. Okay. Can we now upgrade to maybe Spring? Remember, we wanted to upgrade Spring.
Yeah, I think so. I think we should just, in looking at the clock, just jump to step 5, in which we upgraded to.
Okay.
Yeah, why not? We already have seen Neo4j 5 upgrade, and just upgrade to Spring Boot 3.1 and Java 17.
Okay.
Which one did you get?
Let me look at the POM XML. You look at the POM XML. We have 3.1 Spring Boot.
Looks great.
We have Java 17. It's good, no? So our tests look the same way.
Exactly. Nothing changed so far. But your logback XML is gone, isn't it?
No, it's there.
Can you delete it for? Let's see what happens on Spring Boot 3.1.
Can I do this?
Okay, probably it yells at you.
I'll delete it. Okay, let's see. Let's run this. Test containers, cloud via test containers desktop has been found. We are starting the container.
So there's a lot of improvements in Spring 3. What is this? Probably something.
There was a Java agent loaded dynamically. I'm not sure which one. But
there's a bunch of improvements in Spring Boot 3.1 around test containers. So the need for that custom logback XML is gone. The noise of the log has been reduced by a magnitude. So that's quite nice.
Yeah. And also, so we can see the test has run properly and fine, and it's good. But also, this is not just the only improvements that Spring Boot 3.1 introduced, right? They introduced a tighter integration with test containers, which we can show now. And to summarize what the kind of sort of the gist of the tighter integration is that now with the modern Spring Boot, we can expose test containers abstractions like containers via beans, like as Spring context beans. And then the lifecycle of those will be handled by the Spring context, right?
Yes,
so that is one. We still need to configure it. So if we want any particular configuration there, well, let's actually go there. So how do I do this?
I think it's on step 5 if you go to the GitHub Git log.
What? Yeah. Which one did they? Maybe 6.
No, that's all.
Why not? But we are on 5.
Yeah.
Step 5.
That's probably
Let's go. This is the latest and greatest, right?
and check out the latest and greatest.
Force checkout. I don't need any of my
I
commands.
don't
Right,
think you're
perfect.
on.
Yeah. I did the checkout. Look. So now our repository test. It's Spring Boot 3.1, but this is how it looks like. Now, right, it still doesn't expose this as bean, but like we can probably do this. We can probably do this later, right? If I would expose this field as a bean, the life cycle will be handled. So I don't need my before all annotation to start the Neo4j instance. It would also have the life cycle of the Spring context, so it would not immediately work that nicely work with reuse maybe.
That's the reason I did not expose it as a bean.
I think it works though.
Okay.
I think it works because Spring is smart enough to check that if it's reused, then it doesn't stop it. Because I've seen that work in the past, but doesn't matter. So like we can expose the container as a bean. We're going to show it if we have a few minutes of time. But one thing is the service connection annotation. The service connection annotation replaces this approach with dynamic property source that we had. We can annotate containers with that, and then Spring Boot for known container types. Like if you are using something that is very, very popular, like I don't know, Postgres or Kafka, service connection annotation will instruct our application to connect to that instance, whatever we're running in the container, as its default sort of data source for that type of dependency. So if we put the service connection on Neo4j, that will be our main Neo4j database, right? So when we auto-wire the driver will go and find the connection properties for Neo4j, which will be taken from the service connection annotated Neo4j instance.
Exactly.
So where we had the dynamic property source thing was setting the bolt URL. Now we don't need to do this. Now as a developer, it's super, super convenient for me because I don't even need to know what my application needs to work with Neo4j, right? I can just say like, this is my Neo4j. I want 513 because I'm on the modern service connection on top, and then my test can run.
Exactly.
Can it run? Perfection. So they run very, very well. And actually, we should refactor. Let me refactor this. Let me just refactor this. I will do my new Java class, and then we're going to say container config because I want the local development environment mode as well.
Yeah, right? That's kind of cool. And so, I think while Oleg is refactoring here the test, I think what the Spring guys and gals got really right is the dev mode that other frameworks introduced with dev services. So when you expose a service connection like this as a bean, you will be able to run your whole application from the test source tree connected against a service like any service. But it's neatly decoupled from your production code, so there is no chance that there's no possibility that you by chance just nuke your production database because you messed up the URLs. And yeah, it's quite nice.
Right. So, ta-da! With the help of Copilot, it actually was way faster refactoring than I thought. So what we are doing, we introduced the container test configuration that has our beans of Neo4j. So now the lifecycle of this will be handled by Spring Context, and the service connection will make our application to connect to it. So now in my tests, I can just say use that container configuration, and I don't need my instance here. Please stop. I don't need my lifecycle control, and my tests are literally just tests. I don't need test containers. This, right? My test is just a normal test where I would use my application as normal, and I can run it. And it will work the same way. It will go into the container config class. It will find my Neo4j definition. It will start the container. currently with reuse is actually will not stop the container, but it will keep it running because I have my local system configured to use reusable containers as well, and then run my stuff. So we can see if I go here to my Docker, I can tell you. Okay, there are a bunch of Neo4js. There are what? Sorry.
I love your rainbow prompt. That's beautiful.
Check this out. Yes, thank you. So this src main what Java. All right. Oh, this is beautiful.
Beautiful. That's why the long class names, so that you can see this.
Exactly. Right. So we have a bunch of containers started with the different configurations from the previous times. Let me just quickly kill them. I will use my Testcontainers desktop to terminate the containers. Did we do it? Okay, the containers are gone. We killed the reusable containers using the desktop application, which is again a nice feature. Right. So now if I run it again, we can see now we will start the container from scratch. So we will not connect to the existing instance. So we'll take a couple of seconds to start it for the first time, but it will, after the test has passed. This is just to Michael to kind of convince you that Spring did the right thing. Yeah. If I do Docker PS, I have my reusable container running there.
That's cool.
In the thing. Ooh, you know what's cool? Let me show you. Before we get to this. Oh no, after. How much time I have? 5 minutes. Okay. First, I'll show the cool thing first. Right, my Neo4j is running, right, and it's running on. You can see on the random ports, which is a very natural thing that Testcontainers shows and does, because you want to like sort of dynamically generate the config so there are no collisions. If I want to run 2 Neo4j instances, I don't want them to collide on the host ports, because internally the ports are the same, right? Like it's always 7.4.7.3 by default, where we open. I think this is bolt URL, right?
No, that's the web URL, but it's fine. The
doesn't matter.
7687
it's just they are the predefined ports within the containers, but the outside of the containers, if I will map it to the same ports, I will just collide and will not be able to run. So Testcontainers maps on the random ports because the configuration is ephemeral, right? Like we never see it. It's a field somewhere on the Neo4j container instance. So we can take it programmatically. So now if we would like to connect to this Neo4j instance using our normal tools, like for example, the browser console, right? How do you do this? We cannot go to localhost 7.4.7.3, right? We cannot, but we can go to localhost this random value, which is tedious. So again, Testcontainers desktop comes with the abstraction for services, which tells us, look this services. If I open this file, right, and what is that? Okay, it says that all the images that are Neo4j, please map in container port 7.4.7.4 to the high value port, right? And container port this map to not map, proxy local, proxy local port of that value to the container port of that value, right? And this is a soft proxy. So if there are multiple containers running, there are a bunch of rules which container we're gonna proxy to. But the fact is, if I go to this particular port now in my local host, right, I should be seeing the Neo4j browser that
Excellent.
is. It connects. Does it connect? Match m movie return movie. Yes. It connected to our instance and it returns us our movie event horizon. So we can work with the tools, with the dependencies in Testcontainers managed containers as if they are running locally, because this URL is stable, right? I can put it here on in my browser and then just forget about it and always go into Neo4j containers. So that's a cool thing. And that's the services abstraction that they can do there. There are also other things. I don't know, open logs or open the terminal to the container. Right. This is actually cool. I've never been into the Neo4j container. What can I do here? Can I do something?
You could just execute Cypher shell to get you a SQL plus like a terminal connection to Neo4j.
Just okay.
Cypher dash shell.
Okay.
Yeah, like this.
Ooh, and this is Neo4j, and then also
yeah, it's a very good question. Which password it generated, but
yeah, it was password. It was password, right? And then I can do the same, right? I can match my movie here.
Exactly. Semicolon.
Yes. So I can work with my containers in a very, very natural way using the Testcontainers desktop application. So if you are using Testcontainers, check this out. Right. So, and now we're coming back to our Spring Boot, right?
Yeah,
so we could run the tests. And now, can I run this application, but in the, like just the application in the local, if I just develop this application?
If it has been a web application, yes, you definitely could. But I think it's just a command line runner. If you go to the application class, I didn't create a web application really, so it's empty now. How did we manage this now?
Yeah, it's fine. We can show it. We can show it nonetheless. Right? I would get the Java class, and I would say my test application, and sort of I would use the same application like that, right? I will in my main class, right? I would do Spring application from application class, like and then run. And I need to also specify it with the container configuration class. A little bit like this. Sorry, messing up the thing. Why is it not? Why is it unhappy? Do you know why is it unhappy?
No. It takes a consumer. Haven't used that method yet. Let me check.
Do I need to import it? I don't think I need to import it. If you're watching it in chat, suggest us something like how are we doing? What do we need to do?
You would need to call this main method from the application class, so it's a consumer.
Wait.
So if you pass that one is.
Oh, perfect. So, and I can run my code here, run my app. There is a Maven and Gradle targets for running this app, but you can see that it actually runs the app, and it also runs my test containers based setup, which I provided with the container config. So if this application wouldn't stop,
we try to keep the repository simple. It's not a web application this time. It's just a basically empty application with only the repository. What this gives us is a controlled fashion of like having developer connections, dev mode, what it's called in other frameworks. It brings up, it changes the configured connection to your database. Doesn't matter if it's Neo4j or Postgres or anything else, to the thing you want to have against in your while you developed. So we're not speaking about testing this test up. It's about taking the application class, augmented with the additional container config, so that you can do what everybody does. We all say we're doing test-driven development, but in reality, we poke around in the application as well. So that's just how life is. But this happens here in a very explicit fashion, and I like this a lot.
I like this very much as well, because I can control what are the particular container configuration that I'm using for my local environment and my CI. Notice now my local development environment that I use from the app if I want to just explore how it behaves. And my tests, they use the same container configuration. So my tests can be if something fails in CI, I can reproduce locally very, very easy, both just by rewriting the tests and both by just running the application locally. So that is great. And then I can also have full control. And if you used test containers before, right, I think this was a very, very neat design decision by the Spring Boot team. If you have test containers based tests already, you probably have those configurations for the containers, right? Maybe you have particular file-based configuration of the containers, or any sort of more complex, I don't know, have a cluster of Neo4j containers running on the same network. And then you start, and then you, I don't know, something, test against the cluster of Neo4js, right? You can take that setup, put it in the config file, mark it as bin, put the service connections in, or you can also, I think, inject dynamic property source here, registry, right? And then use it for additional configuration. If there is no service connection to your tech, right, you can still have the dynamically created properties for your test or local run. So that is it. I think this is a great setup for Spring and test containers.
So,
and Neo4j.
What's next? Do we have 5 more minutes to show how to run this in other exciting technology, like GraalVM, native image?
Ooh, native image. Yes.
Sure, I don't see why not.
Me neither. Look, I'm using, shout out to the GraalVM team for my default Java version 21 Graal.
Excellent.
Very modern release of GraalVM, which is a build of a package in, I don't know how to say it. I don't remember what it was. It's a Java.
It's a minefield. We don't go there.
No, it's a Java. We can say it. It's a Java distribution. You can download it. You can run it. The Oracle GraalVM Enterprise Edition comes now with the sort of license that allows you to use it for free. So I think this is what I'm running here on my machine. Yeah. Right.
And I think in the last step of the repository, we already included everything in the build file that's needed to make this work on native mode.
This is also decoupling our test configuration from our application. Serves a very, very good purpose, is that if you use anything that sort of analyzes the class path or works with the classes of our application, right? We don't pollute it with, say, the embedded mocks that we started with, because I don't know, and the technologies have come long way since maybe last time all of us looked at them, but I don't think that Neo4j harness is very easy to compile as a native image.
As much as I would love to say this runs natively, no, it doesn't. We are able to run Cypher Shell natively and a lot of other things natively, but not the whole database.
Yes, because it's also there are it's a big thing, right? It's a very big thing. One day, and maybe it's not actually even worth it, because there are trade-offs running in ahead of time compiled mode and in the cheat mode.
But I have to say, you can do other cool things with GraalVM and Neo4j. So we did use for some experiments GraalVM polyglot to have stored procedures in Neo4j that are not written in Java, but let's say JavaScript or Python. That's I think a much more interesting way to combine those technologies.
Oh,
but
yeah.
That would be
I know.
Totally different stream, but not saying that these two things don't match. They match quite well. And
yeah, absolutely.
There's more stuff to GraalVM than just native image, really.
Yes, for sure. No, I love the project, and I'm still following its development fairly closely. Right. So to make our application in the native image mode and test it, we include the build tools plugin, and Spring Boot now supports it very, very well out of the box. And we just say that we test. We want to test and verify, right?
Yes, and I think I put it in a profile, which is activated with the system property native.
Right. So I do Maven and I do -p native, right? And I do what?
D
Test?
native, or we should really use D native.
Why D native? Why not P? It's
Because
profile.
I usually this profile is activated with the property, and
Right.
if you just set this property, it works for if you have a module Maven setup. Then when you specify the profile, it fails for modules that don't have this profile. If you just use a property to activate that profile, it works for all the modules, even those who don't have the profile.
Right. Okay. And
Sorry,
what's the command? What's the command?
That's right. I think
We can look at the README file, I think. But no, I don't think, because it ran the test just once.
no, just default.
Sorry. It just ran the test only once, and it was way too fast.
But it was correct what you entered.
Really? No. Is it just test? I'm confused.
Verify. Let me check. Give me a quick checkout here. Let's check out.
Okay.
If I run Maven -d native, verify, it runs all the things for me. But then,
okay, we did the clean, so let's see. It runs the tests once.
yes.
Okay, and now it starts building the native image.
Yes.
Which is a very fast-paced process. Use 8 threads on my machine. It should be very, very fast.
Oh, my camera is doing weird things again. I'm sorry for that. I'm not.
Right. So what is happening? This is actually, while we look at this, let's talk about this. What is happening? We had our test. We had our JUnit tests, right? This one. And we are building it into a native image with our application and our tests and our test containers based setup. And all of that is compiled ahead of time into the native image. So there is a binary that includes the test. And then on that binary, we execute that test.
It's right? So what Oleg is saying, it's not like a native binary for the application only. It's a big native binary, including the test code and the test dependencies, such as test containers in this case.
Yes, and it works. It works, and it's supposed to finish creating the image in a second now, and it will run the tests and
fail. Excellent. Ah, yes. What about moving back to the head of the repository?
No, I don't wanna. Why would it fail? Why such a betrayal on the from the application? Couldn't institutionalize class bootstrap utils.
While you're looking at, I'm about to. I think we should at some point create a bug report with Spring Boot. The way I set this up, so I don't have any web application in there, right? And we're using @Spring Boot test as a configuration class at the top of this test. And you might
Right.
see that I explicitly set web environment none, right? If you don't do this, it pulls in some classes from Spring Boot or Spring Web MVC, which are not on the class path actually. And with the config I used without the externalized configuration, it all worked.
Yes.
And I
I
think
understand.
by externalizing the configuration here, you annihilate that web environment equals none setting here. So one suggestion I would try with this setup is import test configuration and not using the classes here. I don't know how that behaves, how that changes behavior in total. Like import.
I don't remember how to do it. Let's just revert to this.
Yeah.
What I was trying to say, like imagine those tests pass, and they do pass in this commit, right? Right. So this, I think, if we look at this should work, right? If we look at this, what the sort of what is happening is our test is built into the binary, and then we run it. And while this is a good approach for applications, libraries, when you have a ton of unit tests, and then you don't have maybe a better way to test them. I don't think this works that well for applications, exactly because of the reason, right, you specified. We are compiling the test class path into the native image, right? And then that is the technology where small changes in configuration can have large impact on the outcome. And that means that we would like to test our system as close to production setup as possible, right? So what I would recommend doing for the applications, right? I would have my generic container, and I will say this is my app, and I would have the new generic container. I will put my application, like my app Docker, whatever latest, right, configuration there. I will expose the port on which Spring runs, right? So 8080, and then I will run it, right? So somewhere I would have my app start, stop. And after that, my application will be started. It will be not the normal Java process that I get when I run my normal Java tests, but my tests will start actually the containerized version of my application, and wire it against that. And after that, if this is a web application specifically, I would use it normally. I would from the outside. So I would have something like, how sometimes you'll have the int port, right? And then you would have this Spring like a local port, right? Local server port, stuff like that. And then I
So
would
you're suggesting doing a proper integration test
yes,
into both directions, right? Into the downstream database connection, the upstream database connection, and anything that comes after that from both sides, really.
yes, and the application in the container as well.
Yeah.
Right. And then the only thing, if you already have the integration test that actually use some sort of HTTP calls into your application, then the only thing that you need to change is that you don't configure it to go into whatever the Spring Boot application that when it starts the port is, but you sort of have the port, and you have the port app get map port for get map port for 8080 or get first map port, and just remove this, right?
To make this work, would you need to make the Neo4j container run on the same network like the generic container? I guess so, right?
Yes, yes, that is true. Because for this application, I need to pass my Neo4j information to this, right?
Yes.
So I can do this fairly simple. I will do network, new network.
So my question here was, there's an application that is packaged up as a native image and using Spring Boot integrated helpers to build a complete container image from that. Oleg is putting that into a generic test container. And we want to have a proper integration test into both sides. So, and for that to work, we need to take the Neo4j test container and put it on the same network like the generic container that contains the package application, being it packaged as native image or JVM version, doesn't matter. But they need to be able to communicate on the same Docker network. That's what we're doing right now.
And for that, I can do it very simple. I will introduce the abstraction coming from test containers. I will call it a network. It's a network. I will create the network. I will put my containers on the network. I will have to do that for the Neo4j as well. So here I would say like with network, is network, network. It of course needs to be now static or something. Why doesn't it like it?
The network isn't static.
No, it's now static.
Oh.
And then I would also say with network alias Neo4j. And then that will make my Neo4j instance be accessible to other containers on that network via the Neo4j hostname. And because the containers are in the same Docker environment, I can just say Neo4j and give the static port to it, because it doesn't go through my host system, but it just in the same Docker environment, it just connects to itself to Neo4j naturally on the same network, right? So this would be the setup, and then I will run my tests normally against that and verify my outputs. And with the very simple setup, whether I inject the ports and the configuration into which my test request should go, whether this is the local Spring Boot application or whether this is my container with the built native image, that is just a very, very minor change. You can run it with different profiles if you wish, or in different CI jobs. But that will give you the confidence that your application that is built from your application class paths, in the same way that you're gonna, deploy it. This Docker image can be deployable, right? You test against that and you get high quality results about what the state of the application. So that is it.
For now. Yeah.
Smash that subscribe button to the YouTube channel to see more insightful streams like this one.
And for those who may have missed Oleg's session at Nodes 2023 last week, it is up on the Nodes 2023 playlist that I'll actually drop a link into the chat for that. But feel free to check that out, as well as the repository, which I did link. And that will be also linked in the description as well, so that folks can get out there and look at all of the code that Oleg and Michael covered today. So definitely check all that information out, and we'll look forward to the next stream. And hopefully we'll talk to you, Oleg and Michael, sometime again soon.
I would love to.
Absolutely. If you have any questions about test containers, please don't hesitate to go to testcontainers.com. Then there is a Slack icon there that leads to slack.testcontainers.com. And then you will join the Slack with a couple thousand community members who will be answering your questions about all kinds of test container setups. Michael is there for sure. I think Jennifer is also there if you want to talk about Neo4j. And there is the test containers maintainers team also there, so you can chat with them, and of course yours truly too. Yeah. And I can confidently talk about many subjects.
That's great. Yeah, same applies.
Right.
Thank you for your time, everybody. Oh no, we're already out. Cool.
What do you mean out?
Yeah.
We're still live.
Are we?
I just stopped sharing screen, but we're still live, so
that's good.
We'll see everyone again soon. Thanks all.
Thank you all.